Okay, so we're going to start looking, we're just going to go back to the Phoenix, Seattle one, the one that we've been doing, okay? The only thing, I think that I erased my winds aloft somehow. The ones that I was using on Tuesday in here for that flight plan, so I might have to go and get new winds aloft, but either way, the process doesn't change. It's the same process, it's just that yeah, and we'll compare them. The only thing is we might be switching them, like they might be different, like they might be way different, because if the wind today is different than the wind from Tuesday, then, but it's not a big deal as far as the key concept here is that you're seeing how to do it going forward. So even if we were just pretending that it was the same winds aloft that we had the other day, it's not really that big of a deal. But okay, so let me bring that one up.
So when we do the simplified flight planning and we get our birth to destination, and then we convert it to the time to destination, that's our time en route that we would use?
So kind of say that one more time.
So sorry, when we do the simplified flight planning and we get the fuel, the burn to our destination, and then we convert that into a time to destination on that little chart.
Oh, okay, yeah, right below it, yeah.
Is that our time en route?
Yeah, that's your time en route of just the burn portion, and however much time that is. And then the next one is the reserve for 45 minutes. It's already pre-filled in though. And then, the 2,500 pounds. And then out beyond that is any other, like if you had an alternate, if you had an alternate, which I don't think we've had any plans with an alternate yet, but if you had an alternate, then you would put how much time it is to the alternate and then how much fuel it is above. And then the other two would be like the contingency or the hold fuel. And that's if you added any. So that you may or may not have something in that column, just depending on your flight. You're going to see, once we get into the more, bad weather plans with the MELs and things like that, you'll see those. I mean, you'll be using those a little bit more. But either way, they're just like predetermined amounts. Like if it's 15 minutes, it's 750 pounds. It's kind of like the reserve. Like you're just going to go in increments of 15. Like you're either going to do like 15 or 30, minutes of extra fuel, and then you would just write it in there. So not much of a big step, but okay, let me bring this up. So I'm going to bring this over. That's our packet we've been working on. And let's see here. Let's see if I somehow saved those winds aloft somewhere.
I took a screenshot of the winds aloft if you want me to email it to you.
Oh, for the Phoenix, Seattle?
Yeah.
Oh, yeah, if you do, that'd be great.
All right, stand by.
So dependable, Andrea.
Oh, I'm excited. It's going to be all finished. Having all these unfinished ones is like anxiety.
All right, sent it.
Okay. So Andrea's coming down Tuesday, so you'll most likely be in class next Tuesday night, barring any flight problems, correct?
Correct. I think it's like, what is it, the 2 o'clock flight that gets there from Salt Lake?
Okay, yeah. I might be on the same.
Yeah, it's more the Portland to Salt Lake part that's looking more difficult than that last leg.
Okay. Cool. So anyway, so just to kind of give you guys an idea, if you want to plan ahead. So next week, so she'll be coming down on Tuesday, but we're gonna start working through stuff. So next week, Tuesday, Wednesday, Thursday, Friday, pretty much every single day, if you guys have any time, we'll kind of be having class sessions, available if you want to come and do more, or
any class?
Yeah, it'll be in-person stuff. It may not be here, but just text me or whatever, and I can tell you where we are. We might be at a mix of here because of the class schedules here. We might be here. We might be at the library or wherever. Maybe at SkyWest. I'm not sure, but between
be the same time.
Not necessarily. No, because these are going to be more all day stuff.
Okay. So I took this whole winter off, so I'm good. But I was just wondering because she doesn't get off till 5. So
yeah. So.
Well, neither does Chantel, so wherever you guys are, we can come find you.
Yeah.
Those are day classes.
Well, it'll be a mix. I mean, I can personally do whatever we need. I don't work at all. In fact, I work, I think, 3 more shifts total for the rest of my last day is not until the 26th.
The rest of your career.
But I only have 3 more shifts. I do, as of right now, I work next Friday morning, but I would have from 3 p.m. after that all available. And then I don't work again until the 25th. So.
Same here.
Yeah.
You just use all your vacation time left?
Kind of, yeah. I used a lot of my remaining user and vacation time, but you can't have it end with that. You have to come back and work 1 day or 2 days, whatever.
So with your classes next week, are you going to be recording them?
I can.
Okay.
Yeah. Very easily. Yeah. The record button thing is just a matter of me just hitting the little record thing. I mean, that's easy. I'll be using the computer, so.
Yeah, so even if we can't come,
yeah. I have my son on public entities. That's not.
Yeah. Well, if you want to if you're at home and you want to just log on while we're on, you can do that or record. Okay. Depending on what you're doing, but yeah. Okay, so.
Class final tests. What do you think on that? So we do the flight plan. We can do that from home, but what about the written? What do you want to do?
The written, we would just need to figure out the written. Okay, here we go.
You just set an appointment.
Yeah, like I say, I don't work hardly at all between now and leaving for Kentucky. So honestly, just if you can't do it on Tuesday, next Tuesday, you can do it as early as Tuesday, I should say. But if you want to take more time to study your quizzes and stuff like that, you can. But just let me know when. I mean, I'll have, like I said, I only work 3 more days, and I'm not planning to really travel anywhere. I might have a day or two that I got to if we quickly find a house or whatever, or sell our house, there might be a day or two there. But between now and the 26th, basically the next 3 weeks, I pretty much have off. So it should be pretty easy to find, hopefully just anytime you're available or whatever, if you just want to swing by and you can just take it real quick or whatever, it doesn't matter. So should be easy.
When do you move?
Move, I'm not sure, but my first day is the October 30th. So I might be just commuting at the beginning, but I'm not sure. It really just depends on if we haven't sold our house here. So we need to do that to buy one there, unfortunately. So, okay, so there's the Winds Aloft we'll use. Okay, we've got that. And now let me get our friend Sky Vector back up. Phoenix to Seattle. And this is where I get to remember all the stuff here. Let's see. It was see if I can get this by heart here. It was Zepper, Carlo, Chili, Ramsey, and then Sissy.
Yep. W, 80, J92, LMT, J189, ETG, OLMT, or 2, sorry.
Sweet. Just make sure it did it right, because I know that it likes to mess around with Beatty for some reason. But it looks like it went straight to Beatty and then J92. Okay, so it looks good. And it is the 1048, which was the total distance. Okay, so good. Okay, so now, if this is, let's, pretending that we just got done doing the simplified burn and figured all that stuff out, our next step in this process is to start dividing up the route and basically making it into different segments, okay? One thing that I like to do in this process, I'm going to get into here and kind of show you what I do on scratch paper. Let's see. Create a PDF from file. Maybe not, I can't remember. Not sure where I used to do that at, but anyway. Oh, from blank page. There it is. Okay. Oh, it's coming up over here, of course. Okay, so I've just got like a blank piece of paper here, let's pretend. And what I do here is, so just, like I said, I normally do this just, with a pencil on scratch paper, because this is kind of what I kind of refer to as like some like the information gathering of what I'm doing. So like what I do is I like to kind of draw out the flight plan, or I like to divide it into 3 different segments, okay? So I'm going to just draw some lines here. This would be I call this our climb out phase here. And then I do this, which represents our en route. And then I can't connect those because like the stupid computer will freak out for whatever reason. So, and then our descent leg, okay? So we know we're going from Phoenix to Seattle. So if you want to start typing in information, we know that over here is Phoenix. We know that over here is Seattle. Okay? We know that our cruising altitude is flight level 340. So this portion here from Phoenix to this dot, or this, where it evens out up here, this is what's called our climb out phase of the flight. So from 0 feet climbing all the way up to 34,000 feet. That is our climb out phase. Okay. Once we hit this point right here, this point where we reach cruising altitude, we refer to this as top of descent, or TOD. for an acronym. If you see the acronym TOD, that means top of climb. TOC, top of climb. So that is what this little part right here is, TOC. And this one over here, where we're at 34,000 feet and we're going to start descending into Seattle, is the TOD, the top of descent. Everything in between the top of climb and the top of descent is called our en route phase. And then, of course, from top of descent down to Seattle is just the descent phase. So climb out phase, en route phase, descent phase. Other information that I liked, any other information that we already know, you can also, I like to put it in here. So like Phoenix, we already figured out the ISA temperature for Phoenix. It's ISA plus 20. We figured that out the other day when we were doing the simplified fuel. ISA plus 20 in Phoenix. We have not figured out any of our ISA temperatures for the rest of the flight. This is something that we have to go through and eventually do here. But Seattle, if we wanted to quickly look at Seattle and figure out our, what was the other thing? I need to bring up the actual packet. Load this up in here. Forgot to open it. Okay. Drag this over and in here as well. Okay, so here's our flight plan packet. So we already figured out Phoenix, the ISO temperature. So let's scroll down to Seattle. So there's Seattle. Now, when we look at Seattle, we know that we're not going to be there for 2 or 3 hours, right? So the TAF does not give us temperature information, so we just have to go off of what it currently is, okay? So right now in Seattle, it is 22 degrees Celsius. So with Seattle, I thought I drug Sky Vector over there, but I didn't. Okay. So with Seattle, if we you can come up here and click on it and click on, you can just click on the airport actually and just go into it if you want. And it'll say it right here, 432. So Seattle is 432 feet above sea level. So that's close enough to 500 feet. So with the ISA thing, it's 2 degrees per 1,000 feet, obviously, but it's obviously sometimes easier just to go by 500 feet. So 500 feet is going to just be 1 degree. That's close enough to 500 where I would just say ISA in Seattle should be 14 instead of 15, okay? So ISA in Seattle should be 14. It's currently 22, so we're at ISA plus 8, right?
But it would go to 10, right?
Yeah, ISA plus 8 is the actual, and then chart-wise, we're going to end up on ISA plus 10 because there is no ISA plus 8. But yeah, so ISA plus 10 will be the chart. Coming back to this, we can actually throw that in here. we'll end up using ISA plus 10. Okay, so that's now figured out. So when we do this next phase of the flight planning, basically what we're doing here is we are going to now calculate the real fuel using the actual flight planning charts, and I'm going to show you all this stuff, but we're going to go through and we're going to calculate every segment of the flight. We do the climb out portion as one segment. The descent portion is also one segment. And then the en route portion, depending on how long it is, can be 2, 3, or 4 segments potentially. So if it's a really long flight, like this is 1,048 miles is our total distance on this flight. So our en route section will probably be at least 3 individual sections. Like we usually try to go somewhere between like 150 to 300 miles on one section, but usually no more than that. When we start looking at how we're going to do this, when we divide up the plan, what we do, let's come back and just take a look at our route here for a minute. Ultimately, what we do is we just look for areas that are generally straight. So when we look at this entire plan, you can kind of see, go away. Most of this is our SID, leaving Phoenix. We get up to Beatty, which is right here. And then, we have a big section just kind of going this direction. And I mean, generally, this is more or less the same direction, but, you get a little jog right here where we turn more north. But, so this will be easy to divide from like maybe here to somewhere in here, from here to there, and then from there to up there. And we'll figure out exactly what the points are in a little bit here, but just to kind of give you an idea, we usually divide the en route section up a little bit. But the climb out is 1, the descent part is just 1, and then the en route can be 3 or 4. 2, 3, or 4, I should say. So the very first thing we want to do is we want to go in and we want to figure out our climb out portion. That's the very first thing we're going to do. So one thing that you're going to notice on this that we actually do this a little backwards. It's similar to how you guys already know how we do the flight planning. Like when we are figuring out what our flight plan is, you know how we will find a SID and then go, figure out what the transition is. And then we normally will skip and go to the star and figure out what our end transition is so we know where we're connecting. That's kind of the exact same way we do this. We already know our flight plan. However, the problem is with this is that we don't know, going back to this, just looking at this, going back to this, we do not know exactly where our top of climb point is. And we also do not know yet exactly where our top of descent point is. Okay, so we got to go figure out where those 2 points are along our route, and then we can go in and figure out, okay, there's top of climb, here's top of descent. And just to give you an example, this is not going to be exact, but let's say our top of climb is somewhere between Vegas, or it'll probably be before Vegas. So it might be somewhere in here, and then let's say our top of descent is like Portland. That means everything in between those two is our en route. The problem is we just don't know where those 2 points are yet. So we have to figure those 2 things out, and then we'll know how long our en route portion is, and then we go and subdivide that up. So first thing we want to look at is the climb out. I need to open up the charts here. Okay, so we're going to start looking at our charts here again. Some of these you already have seen, some we've already used, altitude selection, the simplified stuff. So now we're going to scroll down a little bit further, and we're going to go into our, kind of even see they kind of draw the same little thing that we did. It's a little different looking. These climb charts. So they all say climb here at the top. So when we start looking at these, you can kind of see here. It'll tell you what kind of chart it is because it'll say it right here. It'll say climb. But then another big thing that you're looking at is right here. It tells us our ISA number for these charts. All of these charts are divided up based on ISA temperatures. Okay, so this chart right here is a climb chart based on a temperature of ISA minus 10. Okay, so this would be as if it were colder than what ISA was. So obviously we're looking, so for our climb out, if you remember, Phoenix is ISA plus 20. So we are now looking for a climb chart that is ISA plus 20. That's what we're looking for. So I'm going to keep scrolling down. The next one here is still ISA minus 10. The next one is just ISA. That's if the temperature just happened to be exactly what ISA is. Okay. ISA again. Now we have ISA plus 5. ISA plus 5 there. ISA plus 10. Plus 10. Plus 15. Plus 15. And finally we get to ISA plus 20. And it's a climb chart. Okay, so this is, as far as what we're looking for, ISA plus 20 is correct. It is a climb chart, which is what we're looking for. Now the next thing we're looking for is what's our takeoff weight and flight level that we're going to go up to. So we already know the flight level, 340. What's our takeoff weight on this? 70? Wasn't it 74,000 something?
74,404.
So basically 74,500 if we rounded that up a little bit.
Yeah.
Okay, so if you see along the top right here, see this column that says brake release weight? This is 56,000 pounds, 58, 60, 62. So this only goes up to 66, so it's going to be on the next page. That's why you're seeing 2 pages for every temperature. So the next page is still ISA plus 20, and then it goes all the way up. There's 74. Now these are only going even, okay? So there's 74 and there's 76. So one thing about these charts is that if you look at the takeoff weights, they all just go by 2,000 pound increments on the even side, and then our flight levels all also go by 2,000 feet, but they're all odd. So this one is probably the worst case scenario for us because we have an even flight level and an odd weight. Yeah. So as far as our weight goes, we're going to round it up to 75,000 pounds. These charts here are just basically just matching though. Like, so for instance, if we're at 34,000 feet, we're going to obviously be in between 33 and 35. And then our weight is going to be in between 74 and 76. So if you were to just like follow this line over and meet it up with this line, then we're looking at basically these 4 boxes right here. So what we ultimately need to do, and I'm going to show you what the information is in these boxes obviously, but just from the initial point of view here, it looks confusing and things. There's only 2 or 3 things in these boxes that we even care about, that we're even going to use. Okay, I'm going to just show you what everything is in these boxes. So the top left figure is time. Okay, so that right there, that 33.9 would mean 33.9 minutes. The next one below that is the total distance in nautical miles. So 221.1 nautical miles. This figure we don't care about, but that's just our Mach number. The top right one we care about. That is the total fuel burn. And then the one below that is our true airspeed, 393 knots. And then this is our rate of climb in feet per minute, so 494 feet per minute. So what this is telling us is Let's say that we weighed 74,000 pounds and we wanted to climb up to 35,000 feet, okay? I'd be looking in this box, 35,000 feet at 74,000 pounds based on a temperature of ISA plus 20. What this is telling me is that that would take my aircraft 33.9 minutes to climb from 0 feet all the way up to 35,000 feet. It would be 222 miles in distance to reach that, and then your total fuel. Now this fuel right here is for the total fuel, so it's both engines. Once we get into the cruise and route section, it only gives us one engine, so we have to do some more math, but you'll see that later. So this is giving us all of the information we need to know for a plane that weighs 74,000 pounds climbing up to 35,000 feet at a temperature of ISA plus 20. Now, in our case, we're not climbing to 35, we're climbing to 34. And we're not at 74,000, we're really going to have to round up to 75,000. So in our case, because we're caught in the middle, we're having to take an average of these 4 boxes right here. Okay, so the nice thing is, though, is we don't actually have to look at all 4 boxes. All we need to do is find the box that has the highest values and the box that has the lowest values and just average those two, because that'll be the same thing as taking the average of all 4. So if we look at this, 36.1 on the time and 33.28 on the fuel, that's going to be the highest figure I see, and then the lowest one. So it looks like this one right up here is the highest amount, and then this one here is the lowest. So if you just take an average of these 2 boxes, then that's going to give us all of the information we need for this portion of the flight. So the only thing that we need, though, is we need the time, the distance, and the total fuel.
33.2 time.
Okay, so let's do this kind of one by one, and let's go into here. So it's what was it?
33.2.
33.2 minutes. Okay. What is the average distance? Go back into it here. So we're taking 33.28 and dividing it by 29, or 33.28 plus 29.05 divided by 2.
$116.5.
31.16.
25, yeah.
Okay, so we'll just say 31.17. Okay, that's pounds of fuel right there. And then what was the total distance? Distance is going to be 237.3 plus 195.3 divided by 2.
216.3.
Okay, 216.3. So that's how long this portion is, 216.3 nautical miles. And we do, those are the 3 main things that we want. As far as this other one here goes, the true airspeed, 394 plus 386 divided by 2, that will help us. We do need to write it down into the chart, but so maybe figure that one out as well. That should just be 390 even. So 390 true airspeed. Okay, so now you're going to see that the climb out and the descent portions are really easy. Okay, that's it. That's all we needed to figure out. The only thing we have to do now with these numbers is we have to take these, because on our climb out portion we do not calculate wind into the climb out and descent portions. We do not figure wind into the burns. We just take it exactly what it says from the charts. So we're going to start using this page. Not this one, but this page right here a lot more today. So we can go ahead and start filling out some of the information in this page. I'm going to put Phoenix, Seattle, flight level 340. What was the aircraft we were using in this one?
752.
N752 SK. Did any of you guys follow the SkyWest Facebook page? You know?
No, I just didn't want for this class.
Oh, well, like just the SkyWest Airlines Facebook page, so the one that has like 10,000 members. Anyway, so so 752 SK. You should, I guess you know the plane as well. So 752 is that generic 700. It's the one that says, I know that Andrea probably knows what I'm talking about.
Yep.
So it's called Waldo. They always do that. They always do these little things on SkyWest, on the Facebook page. It's like, where's Waldo? Because it's the only CRJ 700 we have that's painted in SkyWest colors. Like it doesn't say Delta or United. It just says SkyWest Airlines on it. And we use it for all our airlines. Like right now, it's actually flying for Alaska. 2 days ago, it was flying for United, though. And then, a couple weeks ago, it was flying for Delta. But anyway, yeah, well, yeah, it kind of is. Like everyone always takes pictures of it. Like, oh, Waldo's in Fresno. Oh, Waldo's in Seattle. Like
it's the only one that says SkyWest on it.
The only CRJ 700 that says SkyWest. We have a whole bunch of CRJ 200s that say it, but this is the only 700. So it's it's a unique plane. It's the only plane like that in our entire fleet of 450 aircraft. So when people see it, they're always like, oh, like just to see where it is, like they travel it around and like it's just crazy to see how much a plane moves around. Like it was in Fresno yesterday, and 2 days from now it might be in Miami, and then it might be in Detroit, and then it might be in Seattle, and then it might be in Salt Lake, and then it was in Aspen a couple of weeks ago. And anyway, 752 is that plane. So it's just kind of ironic that it's one of the planes we use in the class. When we started this class, it was actually painted as a United plane. But then about a year ago, it expired from the United contract, and then we just took it and we used it as a generic, and we repainted it as SkyWest. So anyway, I just noticed that we're using 752. That's Waldo. Okay, so 752, and then just put your name over in the dispatcher column.
What does the POD and POA stand for?
Point of departure, point of arrival. There is no alternate. Actually, I did not. This should have put the flight level. This is what, flight number? This is number 1, right?
Yeah.
Yeah. Okay, selected flight level goes right here. This is 340. We've already got our route in there. Okay, so that fills in all that. There's no alternate. So now this is going to be our segments of the route right here. So the very first one here is going to be Phoenix to TOC, top of climb. It already fills it in for us. This next column here is asking us what is the route that we are flying this on. And the Phoenix to the top of climb is primarily just on the SID, right? So we're just putting in here the Chile 4. And then that flight level just shows an arrow going up because it's the climb out portion. That's not like we're at a specific flight level. We're climbing to 34,000 feet. This next one is our true airspeed, which we just figured out is 390. The next one is our magnetic course. We don't necessarily need to put a figure in on this one because the SID kind of does a lot of turning, so we don't care too much about the magnetic course here. So you can leave, for the climb out and the descent portion, we can leave that blank. We don't necessarily need to have that in there. This next box is asking us about the wind and the temperature aloft. That's something that we use more specifically on the en route portion, which you'll see. But for the means of the climb out section, just put in the ISA temperature. Just put in ISA plus 20. Then magnetic heading is kind of the same thing. It's related to the magnetic course and the wind, so we're not going to, it'll also stay blank for this portion. And then that moves us to the ground speed, which will just stay as 390. So on the climb out portion and the descent portions, the true airspeed and the ground speed always end up being the same figure because we do not calculate winds on this portion. So wind is the only thing that affects that. And you'll see it when we do the en route part, but for now, we're just leaving it like that. The next little part right here is going to be these little columns over here is going to be the segment distance, the segment time, the segment burn. So we're going to come into here, and our segment distance was the 213? 216.3. Okay, so you just have to write it in there. The total time on this one was 33.2 minutes. Sorry, you can't see the period in there. And then the total burn was 3117, right?
Yeah.
3117. Okay. Over here on the far right-hand column is the aircraft weight. This is going to be your initial weight that you have on this is going to be your takeoff weight. Okay, so this was the 74,404. That's what we put in right there. Okay, so as we start doing these segments, so we start out at 74,404. Now, the only thing, as we go down here, we're going to be keeping track of our weight. So this segment here represents our Phoenix to our top of climb. So as if, like I said, from leaving Phoenix, climbing all the way up to 34,000 feet. We know that it burned 3,117 pounds. So now, when we come down here for the next segment, we need to take 3,117 pounds off of our weight because we just burned that fuel. So down here on the next part, somebody want to do the math? 74,404 minus 3,117.
3117.
Yeah.
71,287.
71,287. So that 71,287 pounds is now what we weigh at the top of climb. Make sense? Okay. Because we need that number for our next part. So that is now, we're done now with the climb out portion. Okay. The only thing that we got to do with this now is we need to jump back into Sky Vector. So we know that this is 216.3 miles. We need to go figure out where that is on our chart. Okay. So this is where, like, if you had been manually adding these up, not using Sky Vector, it's probably a little bit easier because you'll see the little segments in there. You'll be able to add them up. So that's one case where the manual charts will probably be a little bit of a help, but either way. These little points right here will show you the distances. So from Phoenix to that Zephyr intersection is 39 nautical miles. So you kind of have to be adding these up to figure out where we're at. Okay, so 39, and then that, if you zoom into it, you can probably see it a little bit better. So then the next little portion is 18 nautical miles. And then the one after that is 28. Everybody sees where I'm getting these, right?
Yeah.
Okay, the next one after that is 21. Now you got to be careful on this because sometimes like that last one I had to zoom in on, but like see this one right here, it's not showing. And I'm zoomed in all the way. Okay, so if you need to go in and figure out what this is, so this last one was Chile, and this should be that Ramsey intersection right there. So now from Ramsey to Sissy, we can't see it because it's not zooming in. But if you click this little button right here, Nav Log, click that button, it'll bring up this little chart for you. Actually, you know what? This is one way, but let me show you another way too. Where was it? Yeah, right there. You can actually click that, and it'll show you right here. So if you come down from Ramsey to Sissy right there, 11.3.
So how do you enter that again, please?
That little button right there, just toggle it. Turns it off, turns it on. Okay. The next one is 77 nautical miles, and that goes all the way to Dubby. So from Sissy all the way to Dubby is 77. Okay, now we're up to 194.3. We're getting pretty close. The next one, if you look at this next one, the Dovey to Beatty, that one is 125 nautical miles. So we know that it's going to go over. So if we add that in, the easiest thing to do is get to a point that you know is close. So at Dovey, that's 194.3 miles from Phoenix, now that we're into our route, right? So sometimes when you know you're close and then you know the next one is going to put you way over it, just go ahead and minus what you need. So let's go minus 216.3. Okay, that's going to give us 22 miles. That means that our top of climb is 22 miles after Dubby, right? Is everyone okay with how I figured that out? Any confusion? Okay.
Yeah. I'm confused.
Okay.
So you added it all up and then minused it by what to get 20?
So our from Phoenix to top of climb is 216 miles. We figured that out in the charts, right? Okay. So we know that it's 216 miles. Those little individual sections we just added up all the way to Dubby is 194 miles. The next section, if we just keep adding on another section, the next section is 125 miles. So that's going to put us way over the 216, right? So we know that Dovey is going to be closer to our top of climb than as if we continued on to the end of the next section. That's going to be like a couple hundred miles past our top of climb, right? Or about 100 miles past. So we know that Dovey is going to be closer because 216, 194, or 216 compared to 300 and something, whatever it ends up being. So all I did is I stopped at Dovey, which is the 194. We had already added up. And then just take that and then minus the 216 that we know is our top of climb. That gives you negative 22, but you just have to flip-flop that and know that, okay, that means that top of climb is 22 miles past Dovey. That's all it is. Yeah. So our top of climb, our top of climb is going to be somewhere right in this area. Okay. The only thing that we care about, we don't necessarily have to go in and figure out right smack dab where it's at and mark it by any means, but you just need to know that it's 22 miles past W. That's it. Okay? Yeah.
So we're adding up all of these miles. We're still climbing at this point, and now we're figuring out, okay, now we've hit our top.
We want to know right at that point that we're at 34,000 feet. At that point is going to be 22 miles past W.
Our W.
Yeah.
Okay,
Correct.
I got you.
So somewhere right in here. There's not a point. Mm-hmm. It's like somewhere right in here, right?
So
okay.
This is now your en route portion.
That's where we would transition to the en route. Mm-hmm. So the only thing we need to know is that it's 22 miles past W. If you want to come in here and write that, you can come in here and put 22 nautical miles. You can just put beyond or past W. I don't like to get it too far into that. Maybe put it up here. Somewhere, as long as you know that it's and just in case you don't, remember it. Okay, so I figured out that. Now we're going to jump and skip all the way ahead, and we're going to go to our descent. Okay. So if we come back to this chart, the descent portion is actually clear down here at the bottom. So that's top of descent. We don't necessarily fill in all of these things. So to Seattle. Start filling in what we know. It's going to be, most of the descent is on a star, and that's going to be on the OLM2. There's not a flight level. We can just put in a down arrow like that if we want. The rest of this we got to go into the charts and go figure it out. So now we're going to jump back to our charts, and you can see this is so this has 43 total pages. So we're going to fast forward. So as you continue scrolling through these, you're going to get now into the cruise section right here. So this goes in order. It goes climb, cruise, descent. So we got to go all the way through the cruise section, and I'm just going to scroll it down here for us. We got to get into the descent. So here's the descent portion. So you'll see it. It says descent. Here's your same thing. It'll show you your ISA, and there's ISA minus 10. And for us, it's ISA plus 10, right, for Seattle. So we're looking for ISA plus 10. So here's ISA plus 10. And then the other element of this is obviously knowing what our weight is, okay? Now, what did you guys show as the landing weight?
62,504.
62.5, essentially 62,504. Okay, so the easiest way to figure out your weight. So the weight that we're trying to figure out here isn't necessarily our landing weight. It's the weight at our top of the descent. Okay, so we actually at this point we really don't know what that is. However, what we're going to do is we're going to just take our landing weight and add 500 pounds to it. Okay, it's usually a pretty safe and simple way of estimating our top of descent. So if you think about how a plane flies and how it burns, most of the fuel on a flight is burned on the going up and cruising. From the point that they start their descent, I don't know how much you guys fly, but one thing you'll really notice about an airplane is when it starts descending, the first thing you feel, if you're a passenger, is you feel the engines basically turn off. And that's essentially what they're doing. They're taking the engines and they're just pulling it all the way back to idle. And most of the descent is just gliding. They're just gliding. So they almost burn. They burn very little fuel from the top of the descent all the way down to where they land. So when I say plug in this 500 number, it's a pretty conservative number. They usually burn 200, 300, maybe 370 pounds-ish, somewhere in there. But it just depends on the flight, obviously. We don't calculate wind on this section either, so we don't care about the winds. So we're going to add 500. So that's going to basically take us to 63,000 pounds. Okay? So when we're looking here, we already know the ISA. We know we're looking for ISA plus 10, and now we're looking for 63,000, and we're at 34,000. So we've got the same problem again with our needing to average 4 boxes. So here's between 33 and 35, go all the way to the right, and then between 62 and 64. So we're looking at these 4 boxes right over here. So let's figure out which is the highest and which is the lowest.
I'm so sorry. Will you go over again in those boxes what each of the numbers mean?
Yeah.
I got the left column, but I didn't get the right column.
Okay, so they're all right here in case you ever want to know.
Oh, okay. Never mind then. I'm good. Sorry.
That's nice.
So each box is the top left corner is time, distance, rate of descent, fuel is the top right, true airspeed is the middle right, and then Mach speed is the bottom right. The only ones we care about, time, distance, fuel, and true airspeed. So we care about 4 out of the 6. The bottom 2 on each side we don't care about.
Okay.
So going back to this here. So these are both 13.5. That's 12.3, 12.6. That's 2/3. So the biggest number is going to be the top left, and the smallest number looks like it is the bottom left. So it looks like we're really going to be averaging these 2 right here. So let's start off with our time here. So 13.5 and 12.3 averaged.
12.9.
Okay, 12.9. Bring that over here and plug it in. It's going to be 12.9 minutes. Next is going to be the total distance. So we're looking at 83.2 averaged with 74.1.
78.65. 78.65.
So 78.7, we'll call it, nautical miles. Okay. Next is going to be the fuel. So 236 pounds averaged with 194 pounds.
215.
Okay, so see this? This one is 215 pounds of fuel. We added 500. So 500 is pretty conservative, but it still works. This is going to end up being 215 pounds. And then just average that airspeed, which is 370 and 362. So 8, so add 4. So it's going to be 366.
Okay, sorry, say that again.
Well, I just did them just in my head. Yeah.
Okay.
So 3.
It's like, oh, I can't keep up.
It's just a difference of 8.
Oh, gotcha.
So I'm just adding 4 to the bottom one. So 366. Oh, I can add and subtract. Very, very low numbers. So 366, right, is our true airspeed. Okay, so we've got all the data now for our descent portion. So we're going to come back into this. We're going to plug all this information in. Okay, so our true airspeed was 366. Because we're not doing wind, we're not going to care about the magnetic course. The thing about SIDS and stars too is you're not like you're doing a lot of turning, so there's not like one true set magnetic course or magnetic heading. So it's another reason we leave them blank. Right here, we're not putting in the wind, but we're just going to put in ISA plus 10. That's the chart that we used. Okay. And we're leaving that blank, and then we've got ground speed of 366. Okay. Now plug in the rest of this information here. What was it? 12.9 minutes?
Yeah.
Or miles. So what was the miles? 78.7, right? 78.7. And then the time was 12.9, right?
Yeah.
Okay. And then the total burn was 215 pounds. Okay. So we'll just leave that as is because we're not going to obviously bring this weight down here because we don't know what all of this is here. So we'll leave this now as that. The big key thing here that we know though now is we know where our top of descent is. And that's going to be, this is going to be going backwards now from Seattle. So you're going to actually go to Seattle and you're going to come backwards 78.7 miles. So let's do that. Figure out where that's at. We're going to Seattle. There's Seattle. You can also use this. You can just scroll all the way to the bottom and just work backwards. In fact, you see this last leg right here? It's 112.2. One thing that I want to look at here for a second. Where is it?
Sorry, for the descent data, do we still use the 34,000 flight level?
Yeah. Yep, that's the descent. That's the cruise altitude we stay at the entire time.
Okay.
Figure out where. It's right here. It's where why is it not showing it? Well, I guess it's in this. Okay, so we got that. We're going to come out of that for a second, and I just wanted to look at something really quickly on that SID or that star. Sorry. I just want to make sure that it's not like skipping points. If I remember correctly, I think it is right, but I think this has a little bit of radar stuff into it. So let's see. Just bringing up that Olympia 2 arrival. Jawbone. Olympia 2. Okay. Battleground, Huga, Olympia. That is Lacey Fort.
So should we just have it up from there?
So direct to Seattle. Okay, so let's look at Sky Vector here for just a minute now. It pretty much is accurate because it's long as it's following the line, but just to throw it in there just in case it's. Let me look at the low chart here. That looks correct. The other thing is, like, this should give us the total. distance. Okay, so it looks like, yeah, it looks like it's fine. I just was wondering why it wasn't having those, why it didn't show those last points. Like there's a couple of like Lacey, Fort, and a couple of more intersections that it hits along this part right here, but the distance adds up to the exact same. So anyway, so this, when you look at this, it's 112.1 nautical miles going backwards from Seattle that's to Battleground. So now if you go all the way to Battleground, the problem is that's going all the way back to here. Okay, that's 112 miles all the way back to Battleground. Yeah, that is one that's on there. So if we have, when you bring up, so this other one that I was showing you guys here, like if you bring up this Nav Log right here, this brings up like a PDF of the whole route. So when you come down here, it actually has those extra points in it right there. You see that?
Oh, cool. So you can see it.
Yeah, you can see the rest of them. Just even though it's not showing them on SkyVector, like as points. So you see right here, Battleground to Cougar, Cougar to OLM, and then Lacey, Arvad, Fort, Seattle. So anyway, so if if it for some reason it's not showing on that little the little one, the mini log inside of the one that I toggled, if you do go into this one, it should have it on there. So extra little step. But so if you go back this way, you can see from Seattle going backwards to Fort is 11.5, and then Fort to Arvad is 6. Arvad to Lacey is 14. So let's just add them up going backwards. So the first one is 11.5 plus 6 plus 14 plus 6 again plus 53.6. Okay, so that takes us a little bit over. So going all the way back to Cougar is 91.1. We needed 78.7, right? So I'm gonna take that minus 78.7, so 12.4. So now this is opposite, so it's gonna be 12.4 before Cougar, right? So let's go back to here. So there's Cougar right there. So it's going to be, since we're coming backwards, it's going to be, if we're heading this direction, if we're heading towards Seattle, then it's going to be 12.4 miles past Cougar. Put that somewhere up here if you want. 12.4 nautical miles past Cougar. Okay. So now we know where they both are. So now our en route portion is going to be from 22 nautical miles past Dovey to 12.4 nautical miles past Cougar. That's now we've got it figured out exactly how long that is. So when we're looking at it from a route perspective, come back down in here to SkyVector. Actually, sorry, we're going to go back to the flight plan first. So our next column here is going to be TOC and then now we're going to start figuring out the points along the route that we want to, how long we want stuff to be. So we're going to go back into Sky Vector. We go back to the world high chart. Zoom out. Zoom back down. Let's go back down to Dubby. So Dubby's right there. We're 22 nautical miles past Dubby, somewhere in this area. So from Dubby to Beatty, we know is 125 nautical miles. So we can already just minus off 22 from that because we already know that we're going to be past. So from our top of climb to Beatty is going to be 103 nautical miles. Okay? So as we keep looking at this, let's just keep kind of going along our route. There's Coaldale there. So from, if we want to look at the distance between Beatty and Coaldale is, it looks like 87 miles, but if you want to come back into the Nav Log, you can actually look at it straight. Beatty, it has this little intersection, Lydat, but from Beatty to Lydat is 45.4, and then Lydat to Coaldale is 41.6. So when you start, the most convenient way to start breaking up the en route portion is usually to use VORs when you can. Like in this case, we can go from our top of climb and just go straight to Coaldale, and that's going to be the 103 because it's 103 to Beatty, and then Beatty to Coaldale is
40.4,
well, it's those, you got to add those two. So Beatty to Lydat is 45.5 plus Lydat to Coaldale is 41.6. So it's 87.1. I was just making sure that it matched this because I looked at it right here in that little box.
Oh, okay.
So that's where I got the number, but I wanted to make sure that it wasn't for another route or something, so I just looked here and added those up. So 87.1 plus 103 is going to be 190.1. So that's a good distance for our first segment. That's right where we want to be, between 150 and like 300. So go back into here, and so top of climb to OAL, that's Coaldale.
You said as long as they're straight, right? So like that one would have turned.
Yeah, you want them generally straight. Now it doesn't have to be perfectly straight, but as long as you're generally going the same direction. So when I zoom out, back out here, we've got top of climb, somewhere right in here, and Coaldale's right here. So yeah, that's pretty much straight for the most part. The next one will probably go from Coaldale. Not that we're worried about it yet, but we can go ahead and maybe start breaking it up. So the next one would be Coaldale. Let's just kind of look along this route here. So Coaldale to Mustang is 127 miles. You can see that right there in that box. And then let's look at the next one. From Mustang, and remember, I'm primarily looking at VORs.
So 183.
Yeah, so Mustang to Klamath is going to be 183. So 183 and 127. It's going to be just a little over 300, right?
Yeah,
310. So that one would be okay. It's a little past where we want to be, but it works. The only other option would be to break it up, break those into two and go Coaldale to Mustang and then Mustang to Klamath.
So you don't want them much more than 300 nautical miles?
Yeah, because once you start getting that long, then you have there's several wind aloft stations, and the wind might be totally different. So the idea here is we're using a segment where we can do one average winds aloft. And so that's why you don't want to have it be too far, because you might start getting the further it is, the less accurate it will be.
Yeah.
So, yeah. So we'll do that though. We'll go Coaldale to Klamath, even though it's 310. We'll just plan on that. And then the last one is going to be from Klamath, and it'll most likely just be to top of descent. So let's go write these in. So this next one will be OAL to LMT. The next one after that would be LMT to TOD. So we've broken this one up into 3 sections. As far as our distances go, you can actually go ahead and write those in because we know them. So if you come over here, this one, the top of climb to OAL was
190.
It was 190.1. Yeah, let's go 190.1. OAL, Coaldale to Klamath was 310. And then Klamath to top of descent, we haven't figured out yet, but we can go and do that right now. Okay, so Klamath right here, it's showing, it says right there 219 to Battleground, which is good to know that. So we know it's already 219. Okay, so there's Battleground, and then that Couga intersection, if you switch back to the low, you'll actually see Couga on there. Okay. So that's showing 10 to Rourke and then 11 to Couga. But if we don't necessarily need to look at that, we can just look right here. Battleground to Couga right there is 21.
You said 219.
So
plus 21.
Yeah, so we were 219 from Klamath to Battleground plus 21 from Battleground to Couga plus 12.4. So this one's going to be 252.4. Okay, good. So the one thing that if you go ahead and do that where you get all your distances like that, go ahead and add them all up and make sure, because you remember the initial distance we had, they should match or be at least really, really, really close. Yeah. 190.1, 310 plus 252.4 plus 78.7 equals 1047.5. That's within a half mile of where we were. So wow. Good, we're good there.
Nice.
Okay, so we've got all that now. Let's come back up here to top of climb to Coaldale. That's the next one we're working on here. So this is going to primarily be via, most of this is on J92, I believe, right?
Sure. Yeah, I don't remember.
Let's go back. Let's go back to the high chart. Zoom out. So top of climb, there's Dovey. So it hits J92 at Beatty. So I mean this area is really kind of no man's land. It's technically still the last part of the Chile 4 because Chile 4 arrival goes all the way to Beatty.
So is there more Chile 4? Or is there...
Well, Chile 4 ends at Beatty. Or sorry, yeah, the Chile 4, the SID actually, the transition is Beatty. So the SID goes all the way to Beatty, and then from Beatty to Coaldale is J92. So
J92 still.
Yeah, I would just go with J92. And that part, it's not going to make a big difference what we put there. It doesn't change any of our calculations, but it's going to be all at flight level 340. Okay, the rest of it we don't know yet. So this is where we're going to go in and start doing the fun math.
Before we do fun math, can we have a quick 5 minutes?
Yeah, sure. Let's take 5 or 10 minutes. Okay, so we're going to look at top of climb to Coaldale. We're at 34,000 feet. So what we need to do now is we're going to bring up those winds aloft. Nice thing here is that we're at 34,000 feet and we don't got to do any side averaging. Okay, so remember, so now on this portion here, we are not using, we don't need to figure out the climb or the descent. So we're really just looking for
the speed, right?
Well, we're just looking for the en route portion. That's all we care about here.
Oh yeah, that's right.
Okay.
So near the middle there.
Yeah, pretty much. So if we think about, okay, well, where was our top of climb at? 22 miles past Dovey, but Dovey was kind of around near Vegas. Yeah. And then our top of descent was just past Portland, really. So we can take an average of just 34,000 feet and go from Vegas to Portland. The thing is that top of climb to top of descent, we broke up into 3 sections, okay? So the first one we're going to use here was we're going to do an average, because the first one is top of climb to Coaldale. So we'll just go ahead and use Vegas and Reno. And then on the next one, the Coaldale to Klamath, we'll use an average of Reno to Lakeview. And then the last one, we'll use an average of Lakeview to Portland. Okay? So the first one we want to do here is Vegas to Reno. We're at 34,000 feet. So we're showing wind 230 at 82 knots. And then Reno wind is 240 at 24 knots. So the average heading there is going to be 235. The average speed, so 82 and 24 averaged. Is that 53?
Yeah, 53.
Cool. And then the last thing we care about there is just going to be the temperature. Okay, so these last 2 things here is that 46 and this 40 right here. That's the temperature. They are negative. So now, but we need to figure out though the ISA. So 40 and 46, so 43 will be the average there, right? So negative 43 is our average temperature, but we need to figure out the ISA conversion. So if we're at 34,000 feet, what should ISA be? Now this is kind of where you get into those way higher numbers. So 34,000 feet, what should ISA be?
So 34 divided by 2.
The easiest way to do it is take your altitude and times it by 2.
Times.
So 34,000, I just do 34 times 2 is 68, and then minus 15 from that. That'll be 53. But remember, this is negative though. So ISA should be negative 53. Okay? So if we are ISA negative 43, what are we as far as ISA is concerned?
Minus 10.
What? Negative 43? Why 43?
That's our average.
Oh.
So ISA plus 10.
ISA plus 10. Remember, negative 43 is warmer than negative 53. So don't be confused by the negatives. So yeah, ISA plus 10 in this case is going to be what we'll use for this cruise portion. So if you want to swing back into your little, if you like this thing. So our first little section, if you think about it from like, I don't know, if you're breaking this thing up from like here to here, and then here to here and here to here, this little this first part. Sometimes I write them down in here, like I'll write in TOC to OAL, and then I'll just put, so the average wind direction is 253 at, I'm sorry, 235, I had that right, at 53 knots, and then we're at an average of ISA plus 10. That's what we're going to use. The other part of this is we need to know, now that we're doing wind, we need to know our average heading in here, okay? So let's go back into Sky Vector. So from 22 miles past Dovey here, all the way to Beatty, we're heading 300. And then from, I'm going to tell what's right there, but if we go into our Nav Log, we go back to Beatty to Coaldale is 308, 312. So it's going between this little intersection, this light at. So 308 and 312. So let's just say 310. Okay. And then the other one was 300. So 300 and 310. So we'll just say an average heading 305 for this section. Everybody okay with how we figured that out? Mm-hmm. And then just go heading 310. Okay, so that's the information we need for this first little section. We need to go in and...
I think it was 305.
Oh, yeah, you're right, 305. Okay. Okay, good. So let's go now into our charts. Back out of this. Flight planning, charts. Okay, so we're going to go to a cruise chart. We're looking for ISA plus 10. Just going to go to the middle here somewhere, see where we're at. It's probably going to still be climb. So here's cruise minus 10, cruise at ISA, cruise at ISA, ISA plus 5, ISA plus 5, ISA plus 10. Okay, the next thing we need to know is what was our weight entering this section. It's going to be right here, 71,287. So we're going to just say 72,000. We always round up. So let's go to the next chart. So ISA plus 10, and then there's 72,000. Okay, and we're at 34,000 feet. So because we're at 34,000, we're always going to be in between this 33 and 35. So the nice thing on this one is that at least we're at 72, so we're just having to look at these two boxes right here. Okay, so when we look at these boxes, these are a little bit different looking than the climb and cruise charts. I mean, they look the same when you initially look at it. There's 6 different little things in there, but the stuff is different in here. So 35, so this one, these boxes, it still will have all of your stuff up here, okay? However, this is going to be like the engine power setting, which we're not too concerned about for us. The next figure, this 1717 right here, and then this 1797, that is the pounds of fuel burned per hour per engine. Okay, so we're gonna have to do some converting in here, and we'll show you how that happens. But anyway, that's what that is. That's the total fuel burn per hour, essentially, for one engine. The next thing we don't care about, the Mach speed we don't care about. The next one is the indicated airspeed, and then the last one is the true airspeed. So 453. So the only two things in here, you guys, there's only two things in these ones that we care about. The true airspeed and the pounds of fuel burn per engine per hour. That's the only two things we care about. So that's all we need to look at. So 72,000 pounds. So somebody average for me 1717 and 1797.
1757.
1757?
Yeah.
Okay. Now take that average and times it by 2.
3,514.
Okay. 3,514. So the reason why we times it by 2 is because we want to know what it is for 2 engines. Because that's 1 engine. So that's another one of the little things we need. So I'm going to do, what was it, 3,514?
Yeah.
So I'm going to write 3514 per hour is what the burn is. Okay, so we'll just put burn. Okay, and then the only other thing we needed from that was so just average, so that's going to be 455. So the true airspeed, 453, average 457, 455, right? My mathematics skills, once again, shining. Okay, 455 true airspeed. Okay, so we've got that. That information now we've got from the charts. Now we're going to have to do, this is now kind of where we're going to have to do our calculations, use our E6B stuff. Okay, so the total distance, let's jump back over to here for just a second. So the total distance on this segment is 190.1 miles. So ultimately, so we've got that part. We need to figure out what our ground speed is going to be. Okay, so if I'm going to come back over here, I'm going to start filling in a couple of these little boxes right here. This is going to be that true airspeed number that we just figured out. It's going to be 455. That magnetic course we figured out, that's going to be the 305 that we just figured out a little bit ago.
I'm sorry, can you tell me where we got that one?
That's your heading.
That's our heading.
That's the heading. Oh,
Yeah.
okay. Write that on there, but that's the heading. 99 courses heading.
Right here in the wind, we are going to put the wind into this now. So this is going to be wind 235 at 53. And then we were ISA plus 10. On here, I probably can't fit it in, but if you can figure it in, like when you write, just write small in that box and maybe put the wind on the top and the ISA plus 10 just below it. Okay, so we've got all that information. Now we need to just simply figure out what our magnetic heading is and our ground speed. This is where we use the E6B. So everybody wants to get those in there. Now you're using the same one as me, right, Caden?
Mm-hmm.
Okay. It's a little weird. You might want to swing around and watch how I do it on mine because it's.
Which one do you guys
Your iPhone?
Yeah.
It's called
PFMA Lite.
Light.
Yeah.
I paid $1 for mine, so it's better to get.
I paid $1 for mine too.
Is it
with
the
E6B?
Yeah, with like the paper airplane on it.
Yeah, it like does all the calculations for you, so that makes it
So is it, I'm guessing it'd be like heading and ground speed, true airspeed, wind direction.
Okay, so I'll show you here. Okay, so the first thing we want so in order to type in the wind, you got to hit the button there, right? You can clear it out if you want because it already has something in it. So we want to type in the wind. The wind is 235, and then you put the slash
Is that the direction?
That's the direction, isn't it? Don't you want to put 53 as the speed?
Well, no, we're doing, so just look at where I'm at here. So 250, so
I see.
I'm putting it in there. So you put 235/53 like that, and then you just select that, and it changes it to 235/53.
Okay.
See that?
Mm-hmm.
Okay, so we come over here. The next thing what you got to do is you got to come over here. Our heading is that 305. Oops, got to clear it out first. 305 is our heading. And then come over to the true airspeed, clear that out if you have anything, and type in 455 and change that.
So that gave me 434 knots on a ground speed and 299 true heading. Is that what you got?
No. Let's see yours.
This is mine. So ground speed is 440.
What?
Oh wait, maybe this is variation from west to east.
No, it shouldn't be. That shouldn't matter.
Okay, I'm gonna get that app that you have then.
Well, let me just see yours for a second. No.
Well,
Aubrey, you just need to calm down.
I want to see too because I have the same app. Heading and ground speed.
Okay, so wait, this has it worded something different. So the course isn't I3.
When did you get to the heading and ground speed?
I just did functions and then
You said that was the heading, right?
heading and ground speed. Yeah.
So it's the
But
heading.
heading right here won't let me add anything into that. Those are my answers. So true airspeed is 455.
This should be 440.
It should be 440.
Or 255 is true airspeed.
Why?
No, you're right. Right, it's 455.
And direction is 235.
Mm-hmm.
And then wind speed is 53. Yeah.
Mm-hmm.
I thought the true course, is that not 305?
Yeah,
Maybe that's what I did.
That's what I put. Was the
That's what I'm
305
trying to-
course, right?
305,
Yeah.
455.
455, 235, 53. Should be 434. See, this is where, I like to see what everybody's varies as. Let's look at that on that one. Okay, true course 305. True heading is 299. Okay, I mean, this one might be off. It's going the other way, whatever.
Well, your guys' ground speed is showing at 440. That's really close.
But
Mine's showing-
compared to these, though, I mean, that's having it 6 knots off is not good. Like
Really?
between two different things. Yeah, I don't know which one's right. That's the problem.
Is there a way to figure that out?
Yep.
Well, mine says
With this thing-
434 is my ground speed.
That's what mine's saying.
So yeah, your guys' might be.
What app did you get?
If you pay for
The
yours,
E6BX
correct.
E6B calculator.
I'm gonna do it manually on this. Okay. Just see what this gets.
I have one of those too.
So you start on 100.
140.
So 235 at 53.
Correct, and then pay $1.40.
I'm gonna watch you do this again because I have one of these ones too.
So I'm starting out just there, marking the wind 235 at 53. So 10, 20, 30, 40, 53 is going to be right in here. Okay, and then now I'm switching this to my heading, which is 3.
Whoa, why did mine go like that? That's weird.
5.
That's going the wrong way.
I don't know.
I got this.
Those apps confuse me.
Go north and then go. What's it? 253.
Well, it's just 53.
So you just go up what? 53, and then what if I change it?
So if I'm heading 305, then I'm going to slide this down to right there.
Yeah, mine's saying it's going way the wrong way now, but that's weird. I don't know. Maybe that's just not.
So is there a way to like clear it out? Put the wind direction under the true index.
Reset. There you go.
Okay. So yours, it should be 235. Wind direction true index. Yeah, it's a stop right on it. Whatever. Let's just keep it on 100 right there. Actually, no, let's just go to 0. There. Okay, we drew it up. Put true course now under the true index, which is going to be your 305. Right there. Okay.
Slide it back up.
Slide the end of the wind velocity line to the true airspeed, which, oops.
Maybe it's not like using these ones.
Just slide that. We go all the way up to, let's say the problem is this doesn't go up to 455, but just go to, the easiest thing is if you just go to like say 255. You see that there? Put that on 255. It would mean that your airspeed's really 240. You just got to convert that now to 440 instead of, So that's how you do it on that thing. But let me see if this is giving me the same number.
That's confusing.
Yeah, don't use that and confuse yourself. There's no point.
I figure if we have one of these like on the test, I wouldn't even have to pull this up, If I knew just how to use that, it'd make it easier.
Yeah, not easier. It's like 10 more things for them. Rather than just putting it in.
No, use a different one.
Putting it in.
So,
the one I just put it in.
So this should be 350.
Maybe.
Well, I mean, it works really well.
So I'm getting like ground speed of like 377.
What?
Well, sorry. I shouldn't give you that number. What I should give you is 400. So a minus, it should be a 20, like a 23, 24 knot headwind. What was your guys' saying?
434 knot ground speed.
Where does it?
So that's a 16 knot headwind, right?
Where does it say
I don't
headwind?
know.
Or from 455, because you got to remember, so take your true airspeed and minus your ground speed. That's what your headwind is.
Oh,
So that would be a 21, wouldn't it? 21.
Okay, so I'm close with this. So I'm like, because I put mine on 400 and I'm thinking like 378, 379. So 21.
You said
That's
it's
pretty
true
accurate.
airspeed minus your ground speed
Is your headwind. Yeah, or your
And yours
tailwind.
was the same as mine, right?
Yeah, I got. Yeah. Are you saying the app, the same app?
No, but like you had a 434 ground speed, right?
Yeah, with the true heading at 299.
Yeah. Okay. It just doesn't tell me for some reason where my heading is coming from. Or where my
Okay, so how do you know if it's your headwind or your tailwind? These stupid questions.
Well, if the ground speed is more than your true airspeed, then it's a tailwind. If it's whichever one is, if your ground speed is less than your true, then it's a headwind, and if it's more than then it's a tailwind. So.
Where are we putting this number?
Which one?
The headwind. For our top of climb to, where's that over here?
Well, we haven't put it anywhere yet. Which one you're saying where are we putting our ground speed or what?
No, I guess, well, we figured out our headwind, so is there somewhere that we write that down?
Yeah, we will in just a minute.
Okay.
Just want to make sure everybody's getting the same number before we move on. So, let's see yours. Okay, well, how do you get back to that original thing? Just go right down like that. Okay. You've got this wrong, that's why. It's 235.
Oh.
Yeah, yours is getting the right number, 434.
Nice.
That's what you guys are getting, 434. Sounds like it's the one we're using is screwy, so we need to get a different one.
This one?
Yeah. And you got 434. Okay. So we need to find a different one for the iPhone.
Looking at this, if our heading is 305 and our wind is 235, that's like an almost perfect crosswind. Like, how does it figure it's a headwind if it's?
Well, part of it is a headwind and part of it is a crosswind. So the total is 53 knots. Okay, so think of your total wind speed. That's 53, right? Well, only 21 of it is a headwind. The rest of it is a crosswind. So that's how you have to calculate that into it.
Cool.
See, the funny thing is that this thing is saying, just seeing if I can get this thing to work at all. It's weird because this will give us the right headwind number. See right there, it says H22, but it's not doing the right math on the ground speed for whatever reason. I don't know. So maybe you just have to disregard the ground speed and take the true airspeed minus the headwind.
I might just go buy the one that they're using.
We're gonna have to try
Yeah.
this one's free.
How about you guys online? What is it all good, or you guys following along here?
I'm looking forward to next week to learn this.
Do you have an app or anything on your phone?
I have a really nice friend, and he actually got me a real metal one.
Oh, the actual manual one, though?
Yeah, but no. And the one that you have, the PMFA, I downloaded it this morning before we started, and I'm just over here like, I don't know. I'm just going to have to see it, I think, in real life.
Okay. Christy says she's getting 434 on hers. But anybody else? John, Jaden.
So what app should we use for the iPhone then, since that one isn't working?
I just bought one.
It's just E6B, and the picture is like a blue paper airplane. That's what I have. It's $1, but it's pretty simple too. In the app, it's not very difficult.
Yeah, not $1.
I've seen that one.
It's so stupid.
It's worth the $1.
Yeah. I can show you tonight, I guess, Jaden.
Okay.
You save yourself $1.
We probably won't really use this after the class, right?
No, shouldn't be. If you are, you're weird.
Matt Boy's over here calling us weird.
Yeah.
Oh no.
No, I'm just saying, the only reason I have it is because I teach the class. So if you have your license and you're still messing around with these apps, then yeah, you're weird. If you're not teaching a class. So, okay. So 34. So 434. So that's the number we'll go off of. So let's go to this. So did you see another part of that where it says your true heading or your course?
Yeah.
True course? It should say like 299 or
299.
Okay. So that is what that represents is it's going to be because the wind is because the wind is blowing, the plane from a side direction, it's going to obviously adjust the heading of the plane. So the plane, even though it's flying on that 305 heading, that 305 magnetic course, the actual plane itself, because of the wind, is pointing 299. Does that make sense? So if you were to think that my pen or this pencil is an airplane, it's pointing this way, but it's flying this way. Does that make sense? So it has like a tilt where, because of the wind, it has to fly sideways a little bit. So, and that's normal for airplanes. Anything that's not on the ground. What's that?
And this one, it shows it like with the red arrow and the black arrow.
Yeah.
So it shows kind of how it's just.
Yeah, that's the way you're pointed. So it's a difference of 6 degrees. It's just like because we're heading 305, but we're pointed 299. So what we do with that is right here, that's going to be this. That's going to be this. That WCA, that stands for wind correction angle. So because of the wind, we have to point at 299. Oops. 299. So now that's what the difference is here. So your magnetic course is 305, but because of the wind, you're pointing 299. And now we can put in that ground speed number of 434. Okay, so now that we know this information, now we have to use this in our calculations for we know our ground speed, we know our distance, okay? So now let's figure out our time. So what is, I know not everyone's a math whiz like me, but if you want to figure out the total segment time, how do you figure out time when you're given speed and distance? Yep.
Our distance was what, the 305?
190.
190.
190.1.
Calculate that.
434.
26.28.
Did you do it? I think you need to flip it.
Should be.
Oh, wait.
Do it the other way. Yeah. You need your distance first divided by your speed.
That's what my flight. The distance.
Oh, just use a calculator.
Oh, I wanted to see if this worked though.
It might.
No, you know what? This is wrong because it's flight time for distance and ground speed.
Yeah. Yeah, this is just, you just want to use your regular. So you guys getting 0.438, right? Okay. So not exactly.
So your distance divided by your ground speed?
Then you gotta go 60 times point.
Exactly. You got to convert it to time. So now take 60 times 0.438. That's going to give you your minutes, 26.28 minutes. So take 190.1, that's your distance.
90.1.
Divide it by 434, your ground speed. You should get 0.438.
Yes.
Okay, now that 0.438, just remember it, right? Now clear it out and just go, you're converting to time now, so you got to go 60 minutes. So go 60 times 0.438.
Oh, okay. 6.1.
So what if it were like 1.438? Would you still do 60 times 1.438?
No, so the easiest thing to do is if you have a number in front of the decimal, that just means 1 hour. So just take out the 1, just know that it's already an hour, and still then just take, if it was 1.4, still take your 0.4, then it would just be 1 hour, 26.28 minutes, if that were the case. But you should never have that, though, because we don't do any distances on segments really longer than 300, and your true airspeed is always going to be 450-ish.
We use that for the simplified flight planning though as well, that same like,
So it was
formula.
distance. So what was our formula? It was the distance times
Divided by ground speed
divided by ground speed.
times 60. Right?
Yeah.
Is there a reason why we use the ground speed rather than the true airspeed?
Because the ground speed is your true speed across the ground.
Right, it's the mileage, like our distance is in the air, isn't it?
Yeah, but it's still measured of how far you're going. The true airspeed is how fast the plane is flying from a power setting point of view. But the problem is because of the wind, it's really moving slower across the ground because of the headwind. And so you have to know the ground speed. The ground speed is really what's going to give you your true distance and how long it takes to fly it. Because when you're talking about fuel, the only thing you want to know is time, right? You just want to know the time because fuel won't have anything to do with movement across the ground. You just want to know how long are my engines going to be sitting at that power level because we know exactly how much fuel they burn per hour. And so we need to know how many minutes they're going to be flying or on, essentially. And then in order to know the minutes, we got to know how fast across the ground. So yeah, you got to use ground speed. We have to know our true airspeed, but the ground speed is what's going to figure out your actual time. So this was 26.28, right?
Yeah.
So let's just say 26.3. Okay, so we're going to be, that segment to fly 190.1 miles is going to take us 26.3 minutes. So now we got to figure out how much fuel that's going to burn. So we go back to this. I think it was, 3514 per hour is what we burn. Okay, so if we burn 3514 per hour, do you remember that same 0.438 number that we already used is going to be the same one we used right here. So you're just going to take 3514 and times it by the 0.438. That'll tell you your fuel burn.
So
Does that make sense?
Is our distance the 0.438?
438 was our distance, right?
That was your unconverted distance into time. Yeah, so that was the 190.1 divided by 434. That should have given you the 0.438.
Okay, but what are all those numbers? Just say like what was the first? I don't know. Give it to me saying things like distance divided by ground speed times 60 minutes. I need like the formula portion of it because I'm getting confused when you say just all the numbers. So I'm not remembering them.
Okay, so the best way is when you first do your distance divided by your ground speed.
Yeah.
To get your time, right?
That gives you the time.
Well,
so then it's
distance divided by ground speed times 60 gives you your time.
Gives you segment time.
Yeah.
So then this is the 35:14 times your segment time.
It's the 35:14. So you have to take just the first part without converting it to time. So take that. So go back to your time calculation. The distance divided by ground speed. Mm-hmm. Before you take the times 60, take the number from before that. That's the number you want.
So
the other way to do this, if you want to separate it and not have it part of that, you can just take your fuel burn, which is the 35:14 per hour. If you want, just take that and divide it by 60. And just get how many pounds am I burning per minute, right? So if you take 35:14, that's your total fuel burn per hour. You want to know how many per minute. Just divide it by 60 and then times that by 26.3.
Okay.
Your total minutes, if you want. So that's the backwards way of doing it.
Yeah. Okay, I get it now. Sorry, it's just you're better at remembering what each ones of these are. So the 35:14 is the fuel burn times
divided by 60. Or if you want to times it by 4.38.
Well, yeah, times it by 4.38, which is the distance from ground divided by ground speed.
So make sure that's 0.438, not 4.38.
That's what I put. I just said it wrong.
Okay.
So it's been like 12 years since I've been in school.
Math class?
Math class, yeah. Okay.
So everybody else, you guys online, everybody good with how we're getting to this number? So I'm coming up with like 1539, 1540. That's the number. So that number represents our total burn.
Okay.
Just call it 1540. And then that will complete that section. As far as that segment, I should say. Now, all we need to do is let's carry our weight down. So 71,287 minus 1540.
69,747.
Okay, one more time.
69,747.
Okay, so 69,747 is our next. Our weight going into the next, so it's going to basically be 70,000 pounds is what we use, round up. So it's going to be 310 miles long. It's Coldell to Klamath. So let's go take a look. We already know it's 310. So the only thing we really need to go look at is our fuzzy looking winds aloft. Okay, so we're going to use Reno to Lakeview. Yeah. Okay, so let's take the average. We're still at 34,000 feet here. This one's going to be a little different because we're showing 240 and 040. So 240 and 40, whatever that is, averaged up. So I'm getting 140. Everybody getting 140? Okay. 140, and then wind is showing, I'm showing 24 and 28. So 26. Good. So showing wind, I'm going to come into here. Just put it right here. $140 at 26. Okay, let's figure out ISA.
Okay, yeah, slow down a little on ISA this time. She did it a little faster than I could figure it out last time.
Okay, Reno and Lakeview. We're still, the nice thing about this is we already figured out, we're still at 34,000 feet. We already figured out what ISA is at 34,000 feet, right? 34 times 2 minus 15 is negative 53 degrees. So what's the average of 40 and 47?
43.5.
43.5. So it should be negative 53 for if it were ISA, but it is negative 43.5. We'll just still say negative 43. So we're still ISA plus 10.
So we'll always be ISA plus 10 en route, right? On this route.
Let's see. Well, I don't know. Let's look at the next one.
Oh, right, because of the different temperatures.
Yeah. We'll always be ISA will always be negative 53 because our cruising altitude is going to stay the same. Mm-hmm. So we don't necessarily need to go back and figure that part of it out, but we just have to compare it against the negative 53 on each segment. That's all.
Okay.
ISA plus 10. Oops, 10. Okay. Let's take a look at our heading. Okay, here you can just look at this, not even looking at the thing. So we're going from Coaldale all the way to Klamath. So that's from here to here.
Just read them to me.
Yeah, just go 299 plus 302 plus 298 plus 297 plus 307 plus 309 divided by 6.
302.
302? Okay.
Will we have these charts?
This?
If we're not using Sky Vector?
Not like you won't have that Nav Log, but it's no real different than just looking like right here. If you're at Coaldale, I mean, in fact, I think by using this, we're actually making it more difficult.
Really?
Yeah, because if you could just come back, so we ended up with 302.
Can we try this? Can we just do it off of this?
Yeah, well, let's just go back and just look at this.
Okay.
We're here. This is the start of the second segment, right? So see this line where J92, see how it says 300 right there? Mm-hmm. So that's heading 300 all the way basically to Mustang right there. From Mustang, now we're staying on J92 here. From Mustang, see now when you leave Mustang, see how it's 314? Now, obviously on the real chart, it's not going to highlight it in pink, but you should know that you're on J92, and that's the one you're going to be following. J92, so now you're at 314 right there, all the way to Klamath. So in this case, you could just go 300 plus 314 and divide that by 2. Well, 300 should be 307, but it's 300 plus 314 divided by 2.
Oh, why did I get 309? That's weird. Sorry.
Mm-hmm. So we came up with 302 using the Nav Log. Remember how I was telling you guys the other day, though, don't like bang your head on the tables about figuring out like a perfect, like using that Nav Log, it made it a little more precise because we took all 6 little points of little tiny jogs, where it turns. We got 302. You doing that way, we just took 2 headings off the VORs and got 307. And that's not going to make a big difference. That 302, 307, it's not going to make any much of a difference. So we'll just use 307 right here. Heading 307. Okay. Now let's go to our chart. We're still ISA plus 10. Okay. We're at 70,000 pounds now, and we're still at 34,000 feet. So it's going to be this box and this box. Remember, there's just the 2 things that we want. Somebody averaged 1694 and 1778.
1736.
1736, you said?
Yeah.
Okay. And then times it by 2.
3,472.
Okay, so the 3472 represents our total burn per hour. Okay, and then the true airspeed was 453, averaged with 457, so 455 again, right? And that is coming from right here, 453, 457.
How do I know our true airspeed?
So this chart is basing nothing on wind. So it knows that if it's windless, that the performance of the airplane will fly at 453 miles an hour under those conditions.
Okay.
At that altitude, that temperature, that power setting, that weight. So it's our job to take this and convert it to the ground speed, though, because they can't give us a ground speed based on that. Okay. Okay, so let's go back over to here. Start filling in this information. This entire one is on J92. It's still at 34,000 feet. Oops, geez, going crazy here. True airspeed is still 455. Magnetic course is 307. Wind is 140 at, what was it?
Where'd you get 307 from?
Right here.
That was, that's our average heading.
All right.
That was when we just did this. We took those two, we started at Coaldale 300
we just got
plus
the 302, so that's why I was
Oh
like,
yeah,
okay.
we changed it to 307.
Okay. Sorry.
Okay, what was the wind again?
140, 26 knots.
26. And it's ISO plus 10. Okay, so we don't know these next two things yet. So let's use your guys' apps. I'll use my whiz wheel. So wind is 1.
My phone was dead. So,
140.
So the course would be on 307.
Yeah. Or if there's an option for heading or course, yeah. 1026. Now we're heading 307.
Well, that just shows you the difference in the seconds on the wind.
Yeah.
It really is, it's like 180. Well, 90 degrees almost.
306.
so maybe it was like this.
Yeah.
306.
Oh, yeah, one.
Yes.
So,
They do all of these for all of them.
No,
Yeah, that's what you me.
I know it's a lot of math.
what your course is and then
Me too.
That we did that one yesterday.
I know I go print all these off, and I think I have them all written down like in here, but I'm just gonna actually kind of like redo them on paper. I'll swap this chair out. Yeah, it's weird because I know that Gary did one,
Yeah, is that blue arrow the blue?
The whole time.
Yeah. So
And so I like redid my weight balance and everything. I was like, I should check all of them.
That's cool. I wish I could put that.
there's something you can put on the
It
Seems like pretty good.
yesterday.
Yeah,
Yeah,
it's not like pretty.
So ourselves and then compare our abilities.
What?
That's what we do.
It's just the E60.
Right.
We're not like leaning on each other.
Yeah. Or like I noticed because when we get together, like one of us is like, something, so we would like say, okay, this is what the answer is, and then move on. And then when I found out when I'm saying it on my own, I was like, well, we never like sat and like, yeah, it was just like, oh yeah, I'm gonna put this, so this is what it is. And I was like, okay. So then I was like, I couldn't shoot all that.
And it just kind of like, it's all on one page. So it was like,
Oh, I see.
that's smart. And then just
totally
do some
before we were just doing like I would just get on the computer and figure it out, and she would just basically do a one
Weight balance.
weight balance
Yeah.
and like start that, and so we basically just trade.
Yeah, and then you
I'm like, this is the airport we're
where
gonna use, this is everything, and she's like, okay, what airport are we using? And then whatever, it's like last night we went over everything, and
Have you started doing your ADM stuff yet? Or are you waiting until you take
I'm gonna take this one first.
That's what I'm gonna do too, so you can do all the notes, all the business together, and put it on the big stuff.
Yeah.
Okay, so I put
And then
E60
take the
dash.
test on Tuesday. Really sick.
Can I take it Tuesday?
Yeah. We can retake it, so I just feel like I want to get it out of the way, and if I can get it done on Tuesday, then I'm gonna do it on Tuesday, so that Wednesday I can start to do.
It's weird. Only one score for that.
Mine's like,
What?
Yeah, I know,
I feel like
I'm gonna restart it, so like completely restart over because.
only problems I got is $20 Monday. Like, it's $150 for that test, and then the practical's $300. 350, yeah. So like,
That's weird. Every time I hit search, it's a different one.
I'm planning on.
So what are you guys getting?
480 ground speed and 306 true heading or wind corrected angle.
It's pretty much almost a straight tailwind, right?
Yeah.
So
Oh right, I forgot about that part. True air speed minus the ground speed.
yeah, almost what like a 27 to 30 knot tailwind, somewhere in there.
Yeah, I got 26. Yeah, I guess it'd be.
So 455 plus like 26, 27. What are you getting on ground speed?
Yeah, I got 480 on ground speed.
Okay, so it's a 25 knot tailwind.
Okay.
Okay. My thing's always going to be a tiny bit off. So if I'm happy if I'm saying 27 on this and it's really 25, then because this is a big old freaking dot, like my dot alone covers 5 knots. So
This kind of shows you like there's the wind, and there's our plane, and then the red one is how it makes it shift a little because the wind.
then what does it say for your wing correction angle then? What does it say for your true course?
306.
Okay, so just one off, right? So because it's just almost a straight tailwind, it's not pushing the nose of the plane off center very much. Then 480 on the ground speed. Okay. Okay, so we're going 480 miles across the ground, and we need to go 310 miles.
Oh. 38.7 minutes.
Let's see. 310 divided by 480 times 60. 38.75. Yep. Okay, cool. We got that. Let's throw 38.7. Let's go just 38.8. Round up on that. Then if we're going 38.8, how much fuel will we burning?
So 38.8 So what was the 310 divided by 480? What did you get?
I can't remember what it is, but you don't. If you want to do it the other way around, though, instead of having to go figure that out, Courtney, the better way might just be take your total fuel number.
38.8.
Well, your total fuel number, 3472.
What? Okay.
This number, 3472.
Okay, that's what we're getting.
Okay, divide that by 60 and times it by 38.8. What you got? What are you guys getting on total fuel?
2241.
So which one did you did? Did you do 38.8 or 38.75?
I did 38.7.
Oh, you rounded down then. So yeah, round up on all of your stuff.
Okay, so it was our total fuel, which was what again,
3472. Divide that down to 60.
57.8.
Times that by 38.8. $2,245.2. Yep, just go 2245.
Okay, and then this. Are we supposed to use the unconverted segment time? Fuel burn times unconverted segment time.
You don't. You can. You can use either one of those. You're going to get similar. I mean, you're going to be within 2 or 3 pounds, which you are, right?
Yeah.
So I just was telling her because it's easier to remember that other figure instead of having to remember the unconverted segment time. But you can, either way works. The math works. Yeah. So the original way was 310 divided by 480 gives you that 0.64583. That's that unconverted time. But let's go the other way. So 3472 times 0.64583. Yeah. 2242 going that way. But
yeah.
At the end of the day, you need to be like within like 1,000 pounds of where the examiner is. So these little 2 and 3 pound mishaps here and there, they're not gonna do much to you. But so now let's take that minus the 2245 and figure out the weight going into the next one.
67,502.
67,502. Okay. Last one is going to be Klamath to top of descent. All of this is going to be on that J189, right? Mostly. Still all going to be at 34,000 feet. Let's go figure out. I'll turn that off real quick.
Paper looks like a friggin' mess.
So what are we going to do? We're going to follow it's just a matter of what order the steps go in.
Yeah.
That's really just That's in the wrong one.
Don't do that. Yeah, I need another break. My head is on fire. Trying to reset.
Okay, so let's figure out the last part of this. Let's take a look at the winds aloft. We're going to go Lakeview to Portland. We're still at 34,000 feet. So we're going to average 040 and 070. So it's going to be what, 055? Okay, so this next one, I'm just going to put it down here because I don't got enough space. What is this? LMT to TOD, right? Okay, 155. Oops. Oh, yeah, you're right. 055. That'll make a big difference. Back to the picture. Okay, so 28 and 25 on the wind speed there.
6.5.
So we'll always round that up. So let's just go 27. Okay. And the isotemperature. So we're looking at negative 47 and negative 55. So this should be
51.
yeah, so 47, 55, so 8, yeah, 51. So on this one you have like it when it's like in between, so yeah, so plus 4, so yeah, 51. And then it should be 53, right? So we're 2 degrees warmer than ISA. So yeah, we'd have to round up to the ISA plus 5. Okay, ISA plus 5. Okay, let's get an average heading here. Let's get up to Klamath. So between Klamath and Battleground, we're on this J189, and so it's going to be heading 333 all the way up to Battleground, which is right here. And then, so like between here and Olympia, we're not on a jet route or anything, but if we look, it still appears to be on the same heading as this line, right? Mm-hmm. So honestly, it looks like we're fine just staying 333 as our average because this doesn't really change. This one's 345 over here going this way, so we're still really close, and it doesn't appear that it's even switching course at all. So So 333 is going to be our heading. Okay. Let's jump to the charts and get the rest of our information. Now we need to go back this direction to ISA plus 5 now. Okay, so I had to go to a different chart, ISA plus 5. We were 67,000 pounds, right?
67,502.
So 68,000. We'd round up. 68. We're still at 34,000. So we're going to be these two boxes right here. Okay, so somebody averaged 1646 and 1732.
1689
times 2.
3378.
3378 per hour burn. Okay. And the true airspeed, let's get back to that. True airspeed 448 and 452, so 450 it looks like. Okay, let's go back to our chart here. We are right here. Leave 450 on that true airspeed. That magnetic course is 333. That wind is 055 at 27. It's ISO plus 5. Now we got to get our apps back out and working again. So I'm going to do mine manually, and you guys tell me what you get. 055, 27, 10, 27. Okay. And then I'm heading 333. So I'm getting about a, I don't know, I want to say maybe 6 or 7 knot headwind.
Yeah.
Okay. What are you getting on correction angle?
336.
So 3 degrees off?
Mm-hmm.
Okay, so 336 on the wind correction angle. And what was your ground speeds?
445.
445. Okay, cool. All right, so we need to go 252.4 miles, and we're doing 445 miles ground speed. Anybody?
34.02 minutes.
Yeah, so we'll just round that down. Let's see, we'll just say call it 34 because I got 34.03. Is that?
Yeah, that's what I did.
Okay. Let's call it 34 minutes then. All right, so for 34 minutes, how much fuel are we going to burn? What was that?
1,915.
I got 1915.97.
So 3378 is our fuel number.
So I
So
did it by the hour. I converted it to per minute. So it might be different than doing the.
I'm getting 1915.89. So we can call that 1916, I guess. So where does that put us then?
Like 65,590 is what I have, but I know I'm a little off.
But how many pounds were you off though?
I got 586, so she's in.
I mean, on that last burn, what was your burn?
My burn was 1915.
Okay, so you're the same as us then. So.
But I don't know how, but my track weight was 505, not 502 with my last one. So I'm just like a few.
Well, because you were like 2 or 3 pounds less on your previous burn.
Yeah.
That's why. So let's say, okay, so 67,502 minus 1916 was what?
I got 65,586.
Okay. Now we're done with that portion. So let's go all the way down here because this one's already done. Now minus another 215 pounds off of that.
Why?
Because we're done.
That's our burn for the descent.
Yeah.
Oh.
We've already done the descent. So we're just we're carrying that weight down now to the bottom.
65,371.
65,371 is our landing weight. Okay, so that should be our landing weight. Now we had like 62,507 originally, remember? So now we've got these numbers down. These are a lot more precise now. These are going to be the true numbers here. So let's take everything else. I like to kind of total everything up on this bottom line down here. So we already did our distance. We already calculated that. It was like 1047.5 on the total mileage. So let's get our time, add that all together. So I just add up like all the minutes first, so 33.2, 26.3, plus 38.8, plus 34, plus 12.9, 145.2 minutes. And then I divided by 60.
2.42, is that 2 hours, 42 minutes? Or
well, that you still got to convert the 0.42. So it's 2 hours and 25 minutes. And that's just the en route time. That's just en route.
And the total burn is 5947.2.
How much was that again?
5947.2.
5947.2. All of that stuff added together, right?
Yeah.
You sure? It seems more than that.
yeah, it's going to be at least
3117 plus 1540 plus 2245.
Oh, you know what? I put a decimal in the
plus
31.
1916 plus 215. So 9,033. Now,
there was a decimal in there. Sorry.
Yeah, that's fine. That'll mess it up. 9,033. Okay, so now remember our simplified fuel? Mm-hmm. That's going to be the key measurement right here, okay? Is how close was our total fuel to our simplified fuel estimate?
We were about over 79 on the burn to our simplified fuel. 7,900.
7.9? Okay. So now do you remember when we took remember how we take the difference between, so we compared the difference from our simplified to our initial, right? Mm-hmm. Our initial was 11.9. Our simplified was 7.9. And so we split the difference and we went with 9.9, right? So this is 9,000. I mean, this ends up being pretty acceptable compared to where we were, right? So that's kind of where when you get to that final fuel number, that's what you want to compare it with. We already got our landing weight, 65,371. Is compare it to that number that we ended up, when we split the difference between simplified and initial. That was, I think we did go with 9.9. So that is what we decided, right?
I don't actually remember that.
9.9, what are you saying that was?
Or our fuel, or en route fuel.
Well, when we got done doing the simplified fuel the other day, we looked at the difference between our simplified and our initial. Most people's initial fuel was 11,900, And so we minus 7,900 from that. It's 4,000 pounds. So we added 2,000 because we split the difference between those two, and that's what we increased our fuel. So we went with 9.9 once we split the difference.
We didn't write that down anywhere, though, did we?
No, we didn't. Not that I remember.
Shoot.
That's fine though. We didn't need to necessarily.
Okay.
So
Was that the simplified burn was 9.9? Because I put 7.9.
Yeah, the simplified you should have written the real one.
Okay.
So if nothing else, you should at least have those two figures if you needed to go back and compare them. So at the end, you kind of want to see where it's all at. So you have your initial, which was 11.9. We had our simplified, which was 7.9. And then we had our real, which was 9, just over 9. So what do you think ended up being the biggest difference, say, between our simplified fuel and our real fuel?
Yeah, tailwind, right?
So if you remember, the simplified is we just did one big average for the whole flight. But clearly, in this case, those averages were skewed because it gave us more tailwind. Instead of, there was really a segment in here which knocked those out, which was way off the average, which skewed it. So, but at the end of the day, even the difference between our real fuel and our simplified fuel was about 1,000 pounds. It was about 8,000, you could say, right, for our simplified. And this one's just over 9. So, it's kind of just interesting to kind of just see where they're at. This is probably a little bit more of a dramatic plan. A lot of times, in fact, most of our plans, I shouldn't say most, but a lot of them you're going to see your real fuel is going to end up coming out within 50 pounds of your simplified. It gets way close sometimes. So this one is kind of exception to the rule because of the winds were so weird on like a huge wind change in there, right?
Yeah.
From the beginning, like it went from 253 and circled all the way around to 055 at the end. So that's pretty big. And then even the speed changed a lot on us too.
So now that we have our en route time, can we go back to our first page and put our estimated time en route and then our estimated time of arrival?
Yeah. So now we take these figures. We're going to plug them all into here. So you can start filling out all of this stuff here. So the burn off is 9033. This is going to give you your real fuel numbers in here. So 9033 plus 2500. So 11,533. Oh, sorry, I put that in the wrong one. That alternate is 0. Hold is 0. That equals takeoff fuel of 11,533. Plus the 250 is our ramp fuel, but remember that's really insignificant to us because we burn that before we take off. But either way, 11,783. And then these, you can kind of just follow these arrows. So this plane back on the 44788, right? So this here is asking for our bow weight of the plane. Plus our payload, which was, payload is going to be 12,216 plus, so 15,216. So it's going to be passengers plus bags. That equals our zero fuel weight. have 60,004. And plus our takeoff fuel, so now these are all the real numbers here.
11.3.
That equals our takeoff weight. Takeoff weight really ends up being 71,537. Then our burn off of 9033 equals our landing weight.
6537.
Holy cow. Is it 62504?
Yeah.
That's exactly what we estimated on the landing weight. It's perfect.
That kind of weird, huh?
That's crazy. And actually, the takeoff weight was pretty close to our first estimate. 74404, 715, so a couple thousand. But
Well, yeah, the interesting thing here is your landing weight normally is going to end up very accurate to what you planned it at. It's going to be the takeoff weight that gets different, you know. So, but yeah, it's crazy. We hit the landing weight right on the nose. So that fills in all of that. This side over here is just kind of, so this is the top of climb portion. It's just asking us, you know, what the totals are. So you just grab this time element is that 33.2 minutes for the top of climb, and then the fuel for the climb portion is 3117. The distance, it's basically just copying that stuff from up there, 216.3, and the true airspeed is 390. And then it's the same thing for the descent here. It is 12.9 minutes. Fuel was 215. The distance was 78.7. And then true airspeed is 366. But these are the numbers you're going to want to use right here for the front page. So now when we go back up here, so you can always just go back and take a look at it. But 2 hours and 25 minutes is the estimated time en route. Now remember, when we do our ETA, we're going to add the 10 minutes to this for the taxi out. So if we leave at 0040 Zulu, 2 hours is going to be 240 Zulu, plus the 25 minutes is going to be 305 plus the 10 for the original taxi out. So it should be 0315 Zulu. And then this is our true airspeed. The average for the flight is really that like 455 number.
So you wouldn't actually take an average?
No, you don't need to. That part's not necessarily anything the examiner's even going to care about or look at. So I just put in which is the most common one we saw, and that was the 455. You can go back and copy and paste your route into this. The taxi fuel, that's always going to be 250 pounds. The estimated en route fuel burn is 9,033 pounds. The alternate is 0. Fuel reserve is 2,500 pounds. There was 0 contingency or hold fuel, which makes the released fuel that, what was it, 11,7. Go back and get it. Well, the release fuel is that right here, 11,783. Now that's before it taxis out. Remember, this is what they're fueling at the gate, okay? But down here, the minimum fuel for takeoff is going to be that 11,533. That's the difference between, it's basically the release fuel minus the taxi fuel. That's what they have to have when they turn onto the runway. If they have anything less on board than that number, 11,533, then the flight is not legal for takeoff. Okay, so that figure right there, that 11,533, and you're going to want to write this down because this is something we talk about and remember. So this is what we refer to this as MINTO, okay, MINTO, and that stands for minimum fuel for takeoff. So MINTO is comprised of your burn-off fuel, alternate fuel if there is any, okay, if you have an alternate, reserve fuel, and hold fuel if you add any.
So not the taxi.
No, because you're talking about takeoff.
Oh, right. Okay.
Yeah. This is the minimum for takeoff. Taxi fuel should already be burned by that point.
What was the last one? Burn-off, alternate, reserve.
And hold. The acronym that we use for this is BAR H. That's what they, BAR H. Burn off, alternate, reserve, hold.
Is there any way you could attach this to maybe today's outline so we can come back and look at it?
Attach.
Like this release, so you or this paper.
Yeah.
Like when you post the video or whatever, we just attach that in our drive so we can look at it. And because I want to fill out. I have to watch our last class and fill out the thing we did last class because I'm still struggling with that.
Okay, that's fine.
So yeah, if you could attach those, that'd be awesome.
A little diagram.
These things and stuff. Like, yeah, we just didn't have our calculator.
That is in there.
Right.
The diagrams.
But the one we did for this plane.
Yeah, she's just saying the one that's filled out, that you filled out.
Oh, you
like
erased
if you
those
Yeah,
now.
those are that's erased.
Dang it.
Yeah.
Okay, but now we have flight calculators, so that
Yeah.
should be easy.
Yeah.
Okay. Before we just were like, oh, how do we do this without things? Yeah, so if you just
Well,
attach-
that part-
something to reference to, you know?
Yeah. Where I was drawing the lines like on the simplified fuel chart.
Yeah.
Okay, yeah.
Well, if not,
It wasn't so much that
part's
part,
fine.
it was just the wind part, right? The averaging the wind and the headwind, that stuff. Okay, yeah, that part you should hopefully be good on now.
Yeah. Yep. Now that we have this, I can get it better.
Maybe if you could add your diagram too, because mine kind of got out of hand a little bit.
Our notes and stuff.
Yeah, you want this one in there, you're saying?
Yeah.
Okay.
That would help a lot.
Yeah.
Because we drew our own, but
I kind of
there's
got.
only so much that fits on.
Yeah, I hear you.
I tried to follow the same thing, but.
Okay, so right here, takeoff. So this is Airport Phoenix. The runway that we chose, what did we choose? 26, right?
I don't remember.
I mean, we have it on this other page. It's if somebody has it, because I just don't want to be scrolling way back there to go get it all. Then the temperature. So this is the planned outside air temperature. That's what that stands for. So, and it was 31, right? Okay, the wind was
312 knots.
Okay, let's do that. So this right here is the planned max runway takeoff weight. That's what that stands for. So what's the max takeoff weight of the 700? 75,000. So that's what we're going to put in right here. Okay. So does anybody remember, you can, I don't necessarily expect that you remember this, but do you remember the flap positions when we did systems?
8,
16. But for takeoff specifically, so just 8 or 20 is the options. Yeah. On most long runways, we always default 8. Okay, unless we're on a really short runway or something like that. So unless otherwise specified, that'll just always be 8. And that previous one will always be 75,000 unless we.
700.
Yeah.
So it's 8 degrees.
Flaps are 8 degrees. Yeah. Our planned takeoff weight is 71. What was it?
$537.
Well, that's what we all had at the very beginning. This is now the new takeoff weight after we calculated the real fuel.
But the planned one is in the height and balance.
Yeah, but these are the front page is always the real numbers.
Okay.
So we are now planning to take off at 71,537. So once we get these real numbers done, this is what we use for the front page. All of this information here.
Gotcha.
So what was that? 71.
537.
537. Okay. That max V1, I'm going to show you how to look that up in just a minute. Over here, landing is Seattle. What was the runway we chose on that one?
34 left.
34 left. Okay. What was the outside air temperature?
22.
22?
Yep.
Okay. What was the wind?
30 at 6 knots. 030.
This is just going to be 67,000 pounds. Okay. Always, unless otherwise specified. Flaps for landing is always 45.
What? Oh, for landing. I was like, why are they different from me?
And our planned landing weight was 62,504. So once you get done with all the real numbers, this is basically when you start filling in all the boxes. Anything that's blank, we go back and we start filling it through. So we're done with the front page other than this max V1. And I'll show you that in just a minute. Everything else on the front page is filled in because there's not takeoff alternate. You just need to fill in, you put in your route here. You can just copy and paste that in. Yeah, you can just put my name for captain.
Captain Salmon?
Correct. Okay, so that's in there now.
It's beautiful.
It's looking good, isn't it?
Yeah, it's so exciting.
We've already got this page all filled out, so we're good here. This is your performance worksheet. So this is just going to be flight 1. I don't really care about the date there. You can put whatever date you want, but it's Phoenix to Seattle. I am the captain. And you guys are, put your own name for the dispatcher. Okay, run, so we already put Phoenix in right there, so it's runway 26. Some of this stuff ends up getting kind of redundant, but 8 was the flaps, the outside air temperature was 31, and then this is going to be, we're just planning that 75,000 is the max, okay? So when you see an M right there, that's telling us that's the max runway takeoff weight. There's not a takeoff alternate, so we'll skip to destination, which is Seattle, and runway 34 left, flaps 45, 22 is the outside air temperature, and 67,000 pounds is the max landing weight. We don't have an alternate. We already put this information in there. So here, this is Phoenix again here. The elevation of Phoenix, I think I want to say it was 1154 feet. We can go back and look though. Once again, your takeoff runway 26. There's not a takeoff alternate. These V speeds and the takeoff staff trim you're going to see in just 1 second. Airport here, I'm just filling in the other stuff. Airport elevation, Seattle was what, 432, right? 437?
I think it's
Okay. Landing runway 34 left. Landing speed, alternate airport, alternate, okay, so we don't have any of that. Okay, so going to bring up some other charts here real quick. Okay, so wrong one. Performance cards. Okay. So these, I'm going to show you some performance cards here. This will take just 2 seconds here. I'm going to upload these for you guys to see now as well into the flight planning section, but these are our CRJ 700 performance cards. So what we are trying to figure out here with these is we are trying to figure out our takeoff speeds, okay? Our V1, VR, V2, and then our landing speed. So what we need to know to use these charts is zoom out here. So we need to go to our takeoff weight. So we're using our real one, 71,573 or whatever it was. So I'm going to scroll down. There's 71,000. So since it's 5, we're going to have to round up to 72,000. Okay. So we go to this chart, and then for our V1 speed here, we're using the flaps 8. So there's an option for flaps 8 and flaps 20. And we are using, so we go to the next thing here is this is basically the elevation that we're taking off from. So this is sea level, that's 2,000 feet. So if you're anywhere in between that, you're going to just round up. So like taking off out of Phoenix, it's 1134. We're just going to round it up to 2,000 because that's only the next highest option. Okay. And then this is, we're going to go to whatever the temperature is. So if it's 10 degrees Celsius or below, then we use this. If it's 20, between 10 and 20, we use that. 20 and 30, that. So it was 31 degrees. So we're going to have to use the 40 actually. We're going to have to round that all the way up to 40. And then we go to the 2,000 pounds, and that is going to give us our V1 speed right there, 135. For the next one, we go down and you use the same thing, and it's actually going to be the same speed. So we're still at 2,000, we're still at 40 degrees, and VR is also 135.
Is that typical?
Yeah, it is, because usually you rotate almost, in this plane it is. So others it's not, but in this plane you pretty much start rotating right when you pass V1. So
all those numbers are like within 1 or 2.
Yeah, almost. Yeah, they all are really close. So you see the biggest difference between 20 degrees and 8 degrees is that 20 degrees you can take off at a slower speed. And that's because 20 degrees flaps creates more lift on the wing. But you can't go as high of weights. But anyway, so 135 and 135, and then the V2 speed is going to be 144. So we're going to come back into this, and we're going to go 135. VR is 135. V2 is 144. Oops. Okay. We don't have a takeoff alternate, so there's nothing there. And then in order to figure out your landing speed, this gets a little confusing because these all say takeoff, but you're going to actually go to the weight that represents your landing weight, even though it says takeoff. So we're going to go all the way down to 62,000 pounds, or sorry, 63, because we're 62,500. So we're going to go to 63,000 pounds, even though it says takeoff. If you come to the very bottom, you go to the landing part right here. Okay. We land at flaps 45, which is over here, and then we use this speed right here, so 130 knots. We don't have to do any temperature configuration or anything, so 130 knots. And we put that one in right here. There's no alternate airport or alternate landing runway. And then the last thing here is the takeoff stab trim. And to figure that out, we stay in this same, I believe it's at the very end of this. No, it's not. It's at the very end of these charts. If you go to the very, if you scroll all the way to the very end, you will come across, never mind. Maybe it is at the beginning of this chart. Maybe I didn't put it in there. Yeah, maybe I just did not put it in there. Let's see. Oh, yeah, okay. I've got a separate document for it. Apparently I took it out and just put it by itself. So I'll upload this one as well. This is called your takeoff stab trim setting. And this is essentially the last thing we look at here. Takeoff stab trim setting for flaps 8. So what we want to know is what our takeoff weight is. So we're 71.5 something, so we're going to round up to 72,000. And then this over here is your CG percentage. If you go to your weight and balance chart, too far. If you look at this right here, go to where your takeoff, where you plotted your takeoff weight and index, and go straight up. See these little numbers that run across the top? Mm-hmm. That is your percent of MAC. And we're just right about that 23 right there. So when we go back to this chart, you're going to look for 23, and then come all the way over to 72,000 pounds, and that is our takeoff stab trim setting, which is 7.2. Come back to this screen. Go right here and put in 7.2. And that should complete everything.
Huzzah! It's so exciting.
4 days later.
Yeah.
4 days later. It only took us 4 days.
Did you do this chart?
Yep. We did that on day 1.
Yeah.
I'll post this packet.
Okay, thank you. No, I do remember.
It's all right here.
I've done it with the other ones, but with this one I never wrote it down. So.
Yeah, it's all right there. I'll post this packet on today's stuff. So week 8, day 5, whatever today is. I'll put it in there along with obviously this video once I get it uploaded. But
That'd be awesome.
Other than that, that is how it all works. So from here on out, now that you know how to do the complete plan, from here, it's just going to be a matter of, okay, well now I'm going to throw some weather at you. You might need to add an alternate. You might need to, do some MEL stuff. Make sure you can go. So it just, from now, we just basically add different dynamics. Maybe we have en route weather that you got to route around it. Little things like that.
So if we have an alternate, do we have to do all the same things for the alternate that we just did?
No, we plan the alternate as direct from the destination to the alternate. You just figure out the distance, and then we have just a flat like speed that we calculate, and we don't do wind on that route either. So it's really easy. You just add it in and you figure out the total, depending on how far the distance is. But when we do that, I'm going to do like a short little video that shows just specifically how to do just alternate stuff. Okay. But the first thing you're going to see is you're going to see MELs first.
Yeah.
And yeah, you're going to see MELs, then some weather, and then combining. So
should we? How much time should we spend going back to fully complete? Because we need 5, right?
Yeah, you need 5 total.
More?
You're going to be assigned more. The thing is, at the very end, you just need to turn in 5. So you can count your final as one of those. So really, you just need to do 4. Okay, because no matter what, you're going to do the final. So you really just need to do 4 outside of here. But you just need to, you can go back and you can do any of them. It doesn't matter. So really, the ones that you've already done, it's just a matter of if you want to go back and practice finishing those up. Okay. So you can do that. I would suggest you do that. Okay. But you're still going to be assigned new ones that you're going to have to do start to finish from now on, basically. Okay. Any questions?
Do you know the schedule next week, kind of when your classes are going to be? Just so we know where to be.
I mean, they're pretty much just going to be
Tuesday here, right?
Tuesday night here, same thing as always. Wednesday, I mean, it'll be, partially like, during the day. I mean, it'll be kind of just a mix of, hours here, hours there. Yeah, of just kind of, you probably just have to text and say, hey, where are we at? What
I was going to say you're going to shoot
I will send an email.
Group saying once we know. This is when we're coming in today.
Yeah.
From here to here, whatever.
Exactly. Yeah.
That would be perfect. Awesome.
We'll do that.
Because I took work off, so I can
cool.
those.
So that's good. Yeah, that'll work out good.
I need a little bit of help with this stuff.
Can we use this one as one of our flight plans?
Yeah, if you go back and fill out your own one, yeah. You couldn't print this and use it.
Right.
But yeah, if you fill out your own, I'm fine with whatever. The 5 flight plans is just an FAA thing. If it wasn't in there, I wouldn't even care if you turned them in or not. I can tell whether or not you can do it just by being in class. So it's just the FAA records has to have them in the file. That's all.
Which I wanted to ask you about my quizzes. I think I still have one from the second week that I was supposed to retake. So do I just let you know?
Do, yeah. Same thing as you do for any of the retakes. Just so. Okay, cool. Well, we will I'll send some more plans out. Like, you won't see anything tomorrow. So if you just want to spend, I would say if you want to spend the next 2 days, Sunday and Monday, just going back through your current plans and maybe going through this part, and then starting Tuesday, we'll probably start, depending on how many of you want to take the final that day or not. If you do come and want to take the final, what you're going to basically do is you're going to come in and I'm going to put you in another classroom to take the final while we do like more flight planning in here. Okay. So, okay?
And that's just the written part of the final, not the flight planning.
Just the written, yep. Okay, we'll talk to everyone later that's online.